first e-learning Wednesday, we're going to be looking at our 3.3 notes, which is function notation and graphing. These notes are in your Chapter 3 packet, and they are linked in the module if you did not get a packet. Remember, if you'd like one, they are available for pickup in the main office. So something to remember as we start function notation and graphing is that a linear function is in the form y equals mx plus b. So what I want you guys to make sure you're doing is follow along and taking notes just like we would in class, okay, because you will need to know this for your test. So y equals mx plus b. Function notation is very similar, except there's one little difference. We write function notation as f of x, so that means write the letter f and put x in parentheses, equals mx plus b. So function notation is almost the exact same, except y became f of x. So function notation just indicates that, hey, this is a function. This would pass the vertical line test if we graphed it. And instead of saying y, we just say f of x. This means there's a function that you're plugging the letter x into. So how this kind of works is that f of x, or you replace, I'm sorry, I wrote that backwards. You replace y with f of x. You replace y with f of x. F is the function, and x is the number you're plugging in, which is your domain. You can also use letters other than f. Sometimes you'll see g of x. Sometimes you'll see h of x. It can look a few different ways. X only replaces x. It does not replace any other letter in the equation. So if I ask you to plug in x, you only want to plug in x values for other x values. So what we're going to do is evaluate some functions. So it says evaluate each function for the given value of x. So you might want a calculator for this part. Now it says f of x equals 3x plus 2 when x equals -2. That means I want you to take the number -2, and everywhere you see an x, you're going to replace it with -2. Well, I see an x here in my parentheses, and I see an x here next to the 3. So that's the only places we're going to put it. So technically, we're just going to plug -2 into our equation. So here's what we're going to do. We're going to follow the same strategy we did last class when we made our t-chart, where everywhere we saw x, we put an open set of parentheses. We're going to do that same thing again. So I'm going to have f, and then there was an x, so put an open set of parentheses equals 3, and then there's an x, so put an open set of parentheses plus 2. Now, in those open sets of parentheses, we're going to plug in the value we were given, which is -2. So plug in -2. Now, on the left, you don't actually have to do anything at all on the left here. F of -2 just says, hey, we plugged -2 into our function. So I want you to just leave that as is. Don't mess with the left. But we are going to simplify the right because these are all numbers. So follow your order of operations. 3 times -2 is -6 plus 2. And then -6 plus 2 is going to give you -4. So that's your answer. We substitute in -2 and we got -4. And now we're going to follow that exact same strategy on B and C. So for part B, it says g of x equals -2x plus 7 when x equals 7. So everywhere you see an x, you're going to replace it with a 7. So let's put our empty parentheses. So g, then there's an x, so put open parentheses, equals -2. And then next to the -2, there's an x, So put open parentheses, plus 7. So here, everywhere you see your parentheses, you're going to put 7. So don't do anything to the left. -2 times 7 is -14 plus 7. -14 plus 7 is just going to be -7. And remember, you can always use your calculator to help you simplify. Then for part C, we have h of x equals -1/2 x minus 9 when x equals -4. So it says when x equals -4, so everywhere you see an x, I want you to plug in a -4. So let's write our equation. We have h, and then instead of x, we have open parentheses, equals -1/2, and then instead of x, put your -4, and then minus 9. I'm sorry, we're not plugging that in yet. Just put your open parentheses and then -9. Now we're going to plug in our -4. So put your -4 in each set of parentheses, and now we're going to simplify. Now don't panic about the fraction. -1/2 is the same as -0.5. You can change it to that if you want. But remember, a negative times a negative will give you a positive. And then once you kind of ignore the signs or you get rid of the signs, it's not that hard to look at. 1/2 times 4 means the same thing as half of 4. And half of 4 would be 2. So +2 minus 9. 2 minus 9 is going to give you -7. Okay, so that's what you have to do for that part. Now, solving for independent variables. Now remember, independent variables, independence, that's your x. Right, we learned that last time. Independent values are your x values. So if I ask you to solve for independent values, I'm actually asking you to solve for x. So solve for the value of x so that the function has the given value. And A says f of x equals 6x plus 9 when f of x equals 21. So we're going to do the exact same idea we did above, where here it says f of x equals 21. So wherever you see f of x, you're going to put 21. Now, something that the f of x, the parentheses and stuff always throw people off. If you look up at the top of our notes, f of x just means y. So if this really confuses you, then you can always just think of it as f of x just means y. So technically, you're just going to take your 21 and plug it in on the left where y would have been. That's all you're going to do. Take the number it gives you, plug it in on the left where y would be. So we're going to say 21 equals 6x plus 9. Now you're going to do opposite operations to solve for x. So I am going to subtract 9 from both sides. That is going to give me 12 equals 6x. And then I'm going to divide by 6. And I'm going to get that x is 2. Or 2 equals x. Either way means the same thing. Then for part B, it says g of x equals -1/2 x plus 3 when g of x equals -1. So g of x is on the left. So you're going to put -1 on the left. So plug your -1 in on the left and then just copy down the right-hand side. -1/2 x plus 3. And now we're going to use opposite operations to solve for x. So I'm going to subtract 3 from both sides. -1 minus 3 is -4. That equals -1/2 x. Now, opposite operations again. I know that fractions, we did this a couple weeks ago. If you're multiplying by -1/2, the opposite of multiplying is dividing. So we are going to divide both sides by 1/2. Or by -1/2, sorry, don't forget about the negative. Now you have to be careful when you do this because dividing by fractions, there's a trick we need to remember. So we can't go to our final answer right away. I'm going to copy this down. -4 divided by -4 divided by -1/2 equals, and then the 1/2's on the right would cancel, equals x. So now when you divide by a fraction, this was back in your chapter 1 notes, dividing by fractions is the same thing as multiplying by the reciprocal. So remember, we keep, change, flip. Keep your -4, change your division into multiplication, and then flip the -1/2 and make it a -2/1. Then a negative times a negative is a positive. 4 times 2 is 8. So 8 equals x, or x equals 8. And then the last one for this part, f of x equals 7x, or I'm sorry, f of x equals -7x, when f of x equals 63. So f of x equals 63, you're going to plug that in on the left where f of x is. So that's going to be 63 equals -7x. To solve for x, do your opposite operation. So we're going to divide both sides by -7. And you're going to get -9 equals x. Okay? And then there's one more little part to this, so make sure you watch the second video with our input-output tables.